This is calculus, topic 7.3. Well, this function, we want to get all the graphing aspects of it, the X-intercepts, Y-intercepts, the concavities, inflection points. So let's start off with the X-intercepts. To find the X-intercept of a function, of a rational function, you take the numerator, set it equal to 0, and solve for x. Here, when I factor x squared minus 1, I get x plus 1 times x minus 1 equals 0. And this implies x is negative 1 and x is positive 1. These are my X-intercepts. To find the Y-intercepts, we set all x's equal to 0. So we get 0 squared minus 1 over 0 squared plus 1. And as a result, our Y-intercept is 0, negative 1. Now, to find the max and mins, let's say max and mins of this function, we want to take a derivative, a first derivative, and I have to use quotient rule. I'll have x squared plus 1 times x squared minus 1 derivative minus x squared minus 1 times x squared plus 1 derivative all over x squared plus 1 all squared. Now the derivative of the x squared minus 1 is 2x here and also 2x here. So I want to factor out those 2x's, leaving behind the x squared plus 1 and negative x squared minus 1. And again, I'm just using the numerator only because only the numerator will be set to 0. So it's 2x taken out, leaving behind x squared plus 1 and minus x squared minus 1. Now I'll begin to clean this up. By distributing my negative, we'll get a negative x squared and a positive 1. So we'll have 2x, and the x squares will cancel, and the positive 1s will combine for 2, and we'll end up with 4x. Now we'll set that equal to 0, and we'll find that x equals 0. Now we don't know if that's a max or min until we create the second derivative and place 0 into this. So this is either a max or min, or neither. Sometimes it can be neither. But let's find the second derivative. So we know the numerator for the function f of x is 4x. So let's recreate the function. 4x all over x squared plus 1 all squared. And our second derivative, we'll again use the quotient rule. We will have x squared plus 1 all squared times 4x derivative minus 4x times x squared plus 1 all squared derivative. And then we'll square the denominator, which will give us x squared plus 1 all to the 4th power. Now the derivative of the 4x will be 4, whereas the derivative of this, with the use chain rule, we're going to get 2 times x squared plus 1 to the first, plus 1 all to the 1st power, and then times the derivative of the inner function x squared plus 1. Okay, so let's just use the numerator. So what we'll have is a 4 and x squared plus 1. Here a minus 4x, a 2. The derivative of this will be 2x, so we'll have a 2x here, and then we'll have our x squared plus 1 there. Alright, it's a lot of factors. Okay, out of all this, I can take out a 4 out of both of these, and an x, got my square, and an x squared plus 1 out of both of these. So let's factor those out. 4 and the x squared plus 1, and that'll leave behind another x squared plus 1. Let's see, the 4 is out, but that leaves the x, the 2, and the x here, and all that makes 4x squared. Okay. Now these two can be combined, and we can get a 4x squared plus 1. A 4x squared plus 1 here from that. And all this combines to become a negative 3x squared plus 1. All right, I'll pull that negative out. We'll get a negative 4x squared plus 1 and a 3x squared minus 1. Okay, and that's actually our numerator. All right, so when we solve for x here, for this set equal to 0, we're actually going to get 3x squared minus 1 set equals 0, and this implies x equals plus or minus the square root of 1/3. Okay. Now the reason why I solve for the numerator, or this right here, equal to 0, is this is giving me now inflection points. Now I want to go back and use this as a numerator and go back and get my old denominator so I can put x equals 0 inside. Okay, so put my derivative back together. Negative 4 x squared plus 1, 3x squared minus 1, and that's all over x squared plus 1 all to the 4th power. Okay. All right, so let's put the 0 in there from there. And we'll get 0 here and get 1, 0 here, get negative 1. So 1 times negative 1 is negative 1 times 4, which is positive 4. And then 0 here will give me 1. So it'll give me 4. So this is positive. So since this is positive, this means that x equals 0 is a min. Okay. All right, so I think those are all the things that we have. We have an inflection point at x equals plus and minus the square root of 1/3, and we have x equals 0 as a min. Oh, also, this function right here, the second derivative will stay negative because of that negative here until this portion right here becomes negative. So this stays negative, so that means it'll stay concave down. It'll be concave down from negative infinity until we hit this intercept right here, which is at negative square root of 1/3. Okay. Then once it gets past negative square root of 1/3 until it gets to the positive square root of 1/3, it's going to be concave up. Everything's going to be positive. So from negative square root of 1/3 to the positive square root of 1/3, that's all concave up. Now once we get past the positive square root of 1/3, then it'll be back to concave down, or the whole thing will be negative, because the values in here will be positive. The values in here stay positive, the values here stay positive, but this is a constant negative 4. So positive, positive, positive with one negative gives you negative. So then that means that your function is concave down. So from square root of positive 1/3 to positive infinity, it's all concave down.